Hello everyone, thank you for joining MYCOM OSI's Autonomous Networks webinar. We've got some great guest presenters today. We've got Chris from Omdia, my colleague Jithu from MYCOM OSI, and Aygul from AWS. They're going to be taking us through the agenda, which is up on screen over the course of roughly the next 45 minutes. Just a little bit of housekeeping. On the right, you should see a chat bar. Pop any questions in there that you have based on anything you see on screen, and we'll have a Q&A right at the end. There's also space for some polls and some handouts, which we'll intersperse through the next 45 minutes. So I think with much further ado, it's over to Chris from Omdia. The stage is yours, Chris.
Thank you, Jack. Hello, everyone. Chris Sarantopoulos, Senior Analyst for Omdia. And to get things started, I would say that I think we've reached the point that the need for more automation within service providers networks is more apparent than ever. Service providers are under what I like to call a triple pressure. The first thing is that their networks are becoming increasingly complex. The whole cloudification story has created a completely different network stack that they were traditionally required and used to manage. Now we have several different layers that don't fall under the traditional CSP skills. The other thing is that there is a requirement for more on-demand and type of services, the type of services that hyperscalers like AWS and so on offer. This means that there is a requirement, especially in enterprise and business customers, to be able to spin a new resource or a new network element in an instance and establish a service within minutes. And also at the same time, the whole 5G investment has not paid out what it initially promised. We see that more or less the ARPUs remain flat for the same service providers, or they fluctuate not in comparison with the level of the 5G maturity. And there is now a new need to find new revenues, and these revenues can only be accessed if what we discussed earlier, this type of dynamic on-demand experiences are offered. So automation is the answer to both three of those issues. Now, our latest research that we conducted in the last quarter of the last year shows that the level of maturity of automation within service provider networks. So we asked the participants to evaluate the level of maturity of automation within their network, within specific domains of their networks, based on the TM Forms Autonomous Networks framework. So level 0 means completely manual operation. Level 5 is the full autonomous operation. And we found out that less than half of the CSPs have moved beyond level 2 of automation. So this is level 2 is where AI is still primarily for more monitoring and recommendations rather than making autonomous decisions. So even among the leading operators, progress remains quite fragmented. We see that there are some outliers within this table responses that map their networks within level 4, level 5, but personally, I would take those with a pinch of salt, and I would say they are over optimistic. So where we are right now, we've seen some automation and some level of maturity in specific use cases. So some operators have successfully automated individual domains or individual uses within one domain. So, for example, the run self-optimization is a use case that can be easily automated, or the transport SDN or service assurance in the core network can be offered with AI capacity. But in reality, in true cross-domain coordination, cases are very, very rare. And according to our research, only 28% of the operators have deployed some sort of multi-domain orchestration. And this really illustrates a gap in multi-domain integration of automation that is the ask for level 4 autonomous networks. Now to move to the next slide. We also asked in the same survey, what are the biggest challenges for progressing further with the automation solutions in the automation journey? And most respondents said that interoperability, integration with existing systems, and the employee skill set are by far the top roadblocks there. And we see that legacy architectures that exist or coexist with newer systems is it's very hard to bring together and integrate and automate within the same workflows. Also, the workforce has these skill shortages, and personally, I would add AI trust as one of the big issues for one of the big issues there, because operational teams that are used to managing the network and know it as a have huge experience, work on it for many years, and they are not very eager to pass these responsibilities to automated systems. And more or less, these automated systems have to prove themselves in order to be able to be trusted. Now, we see service assurance as the control loop within this whole closed loop automation story. And service assurance definitely has this role of taking feedback from the underlying network conditions and using a common inventory, passing this information to automation and orchestration systems that take the actions. And from what we see in TM forums, phased approach towards level 4 autonomy, we see service assurance as one of the high value scenarios for phase 1. Phase 1 is some initial steps that are defined based on their operational value and also their technology feasibility. So within the industry, service assurance solutions are acknowledged as mature enough to be and capable enough to be able to gather data and correlate from different generations and different types of network infrastructure. So we also see from a TM forum survey that service assurance and fault management, that for me fall under the same category, that is network traffic visibility, monitoring, and service assurance. They're more or less part of the same story. These are the processes that need to be addressed first with high priority. So without taking more time, I will pass over to Jithu to tell us more about MYCOM OSI solution.
Thank you, Chris, for the great introduction through your market research results and insights on autonomous networks and automation, right? So good day, everyone. I'm Jithu Raghavendran, Vice President for Telco Transformation and Automation / AI Solutions at MYCOM OSI. So over the course of the next 15 minutes, I'll actually provide a summary of MYCOM solutions to build autonomous networks using service assurance capabilities, including an exciting demo that we have actually lined up for you of the AN autonomous network use cases in production environments. So I'll start off with a case study that we actually derived from the MYCOM OSI's value realization framework on how we evolve the autonomous network scoring from level 1.8 to level 3.3 in this example of that case study through proven results at a tier 1 CSP that's actually providing mobile, broadband, and enterprise services for their subscriber base. Firstly, we automated a range of mobile and broadband services in service assurance domain by reducing over 85% in incident handling and also automating 600,000 person hours, taking into consideration over 300 service impacting alarms exclusively through our domain expertise embedded into our solutions, all leading to over about $6 million worth of cost avoidance. We then actually progressed towards automating the enterprise services provided for their B2B customers by automating 64,000 person hours and 99% of their workflow processes in their enterprise and IT network. Thirdly, through the introduction of automated customer impact analysis solutions, we were able to improve the mean time to repair by over 50% and reducing the customer compliance by over 90%, right? Then by progressing towards that zero-touch network operations center, wherein we actually were looking at reducing the incident handling times over 97% and auto remediation solutions leading to a total of about $5 million worth of cost savings as well. And last but not the least, we have been able to improve the operational efficiencies of the network operations center and the service operations center teams by proactively identifying the incident reporting as well as enhancing the quality of service by over 2.5 times by actually providing that better network visibility, all leading to also workforce reassignment to high priority tasks such as accelerating the rollout of FTTX and 5G standalone networks and so on. The next one I wanted to actually quickly go into is how do we actually kind of look into the autonomous network levels and the mapping. I mean, Chris obviously kind of provided that from a market research perspective, and we adopt several standards and more specifically TMF recommendations, for example, IG 1326, on how we actually evolve digital transformation from level 2 to level 4/5, and have developed several assurance and automation solutions to go from assisted operations and maintenance to highly autonomous capabilities in this journey. I'll summarize the blocks so as to what it actually takes to go from one level to another, starting with level 0 to 1 with predefined, pre-configured rules for basic automation, moving to level 2 with selected autonomous actions for individual domains in a CSP network, to level 3 with higher level of automation with intelligent correlation methodologies, and moving to remediation, automated remediation solutions to level 4, and also actually providing AI-based use cases for complicated or complex cross-domain predictive analytics, including RCAs. And then to actually kind of move into level 5 with the introduction of some of those intent-based automation capabilities. The bottom table actually provides like how the impact of actually moving from one level to another, as you can actually see the shift from personnel to automating the systems in the landscape as well. So the next one is to evolve towards autonomous networks within MYCOM OSI. We actually believe the key components in this journey as a must-have that's actually highlighted in this slide in the form of auto detection for level 2, followed by auto correlation, ticketing, and dispatch for level 3, and automated remediation for level 3/4, and AI-based remediation for a true level 4 capability. We'll go through some of those details of each component in the coming slides in the presentation. So firstly, we actually start off with the auto detection of network and service problems. The key pain points for the CSPs we have clearly observed are automated and accurate detection of network and service degradations, as well as faults without any human intervention. And how do we actually kind of solve this? Firstly, it all starts with the accurate representation of the service model, as you can actually see in the bottom right, on how do we actually model the network to resource to service layer to the customer impacting layer, right? From resource to service customer topology, and how intelligently we ingest the different data sources such as PM, FM, probes, topology, and also the enabler towards the cross-domain correlations in each layer. So this allows us to accurately identify the service KQI degradations, such as latency, throughput, application, load times, to name a few, as well as the network degradations, such as interface availability and round trip times, and all summarized in a single pane of glass, as you would actually see on the top right. Then we kind of move on to the auto correlation, right? This then, provides that whole correlation between the network service, IT/application data, which we commonly refer to as the triple correlation problem that we are actually solving here. The key pain points for operators today is that you have disparate systems and data sources, disparate data sources for mobile, fixed, and enterprise services. And it's actually extremely laborious to actually bring all of those different sources together. So this is how we actually do it, by effectively introducing the triple correlation methodologies and algorithms between the application, IT, and the network layers, and also to actually create that dependency to actually map it all the way up down to the underlying network routers, switches, firewalls, and all the network related resources. And over here, the key thing is the provision of automated workflows and correlating those different data sources through propagation models within the service models that I explained earlier, to detect those outages and accurately provide those corrective actions as well. And the screen actually indicates how multi-dimensional consolidation of those different data sources all in a single pane of glass that we are actually showing. And then we move into the auto ticketing capabilities. Once after you've correlated, one of the key problems in the with this, which the CSPs face today, is they are kind of like behind a huge volume of tickets and not actually able to actually understand which ones are accurate tickets, and how do you then actually also reduce those ticket volumes along with the accuracy at the same time. And this is where our ticket generation capability, as well as the solutions that we have implemented across the various domains, is so accurate to actually kind of provide you with the owner group information, severity, the root cause details, the impacted network elements, right? We've actually seen 25,000 tickets actually generated per day, but actually improving their accuracy by over 98%, and also reducing those ticket volumes so that you can actually kind of deal with those specific tickets which are actually service and customer impacting. And along with it, of course, we actually kind of provide very robust integrations with external systems through API integrations to CRM, billing platforms, as well as providing an escalation matrix, mapping some of the penalties and the KQI breaches, especially for enterprise and wholesale groups. Then we move into the auto dispatch for the field engineering teams, with the problem that we are solving, especially with the complexity of those RCAs, where the last mile is exactly the big problem, and the need for automated dispatch to specific expert groups. And this is where we've actually gotten the auto dispatch solutions for field engineering teams, which actually maps that as exact root causes to the specific organizations that are actually dealing with the truck rolls and the on-field troubleshooting and the remediation teams, right? That dispatches can actually be by various different forms as well. That then actually gets fed into the auto remediation, where the RCA times are actually very long and no automatic problem resolution is actually provided. And this is pretty much where the big problem of how do you actually identify and map those remediations to the specific root causes is one of the biggest issues which we are actually solving here, by comprehensively actually providing a framework in order to actually have pre-built auto flows, if you like, for several scenarios in mobile, broadband, enterprise, wholesale, you name it, right? Based on those remediation actions, the system updates the changes in terms of the port resets, as the configuration changes, and so on, and just to name a few typical use cases. we've actually provided some of those advanced use cases that we also actually deal with respect to the BBU, CPRI interface fails, hell unavailable, MTP routes for transport devices, for broadband, and so on. And lastly, it is actually also kind of, in order to truly move towards autonomous network level 4 capabilities, the specific problem statement over here is how do you actually introduce the AI capabilities for various different scenarios, such as predictive analytics, forecasting, and anomaly detection, which is actually a key requirement for it. And also to actually help operations engineers to identify the problems predictively rather than even actually proactively or reactively, right? And how do we actually do it? And the first and foremost, it is actually how comprehensively we actually combine, correlate, and also actually use machine learning algorithms and pattern discovery for specific network segments, right? And on the right-hand side, on the top, you actually see how we then actually map that multi-lens anomaly detection for IP, VLAN, ports, applications, specific KQIs for different services, and so on. And comprehensively, these algorithms are actually inbuilt within our solutions that allow you to predictively actually find those problems. And then, the usage of multi-large language models and GenAI capabilities using natural language problems. And this is exactly where we actually harness the power of cloud-native applications, such as like the solutions that we are providing, including our strong partnership with AWS, in order to actually also integrate with Amazon Bedrock, providing foundational models such as Claude 3 and Mistral for some of the generative AI capabilities. Aygul will no doubt actually later on provide an excellent overview of how the cloud services allow CSPs to build automation in their environments. And our AI solutions leverage the network domain consolidation, the data normalization, automation, and intelligent remediation of these issues through some of these underlying models provided also through this integrated AWS GenAI models that we have actually kind of been proving with our customers as well. With that, I'll actually move into the next segment of the webinar, where I'll actually play you a demo where you'll see these solutions we described in action. And I'll fire up the demo in a second.
As the CTO of a large converged network, I want excellent quality of the network and services, and to save millions of dollars because of manual operations and uncorrelated data. I begin my day by checking my network and services health, scanning by telecom technology, network region, or domain. Today, my dashboard has auto-detected a degradation in mobile and fixed broadband data services. I want to resolve the problem without human intervention. MYCOM OSI's automation solutions enable me to achieve 90% reduction in alarms, 85% reduction in time to repair, and hundreds of thousands of automated person hours every year. Let's see how. I see that the solution has activated an automated correlation between performance, fault, network topology, and incident data. This correlation of multiple data sources helps my team identify the root cause of service quality degradation for a specific technology, domain, and location. For example, to identify a RAN site degradation, the system looks up the key performance indicators and checks for any site network alarms. It also checks the site coverage and location. In a single view, I zoom into a network element for its performance, faults, and incidents. If a degradation is detected in the mobile core network, the system checks the service performance of each link. The engineer instantly visualizes the health of the core network nodes by checking KQIs, KPIs, and fault alarm status. This solution works for fixed broadband networks too. My operations team can monitor different fixed service types, links, and network elements, and assesses customer impact. For fixed broadband issues, individual customer-level performances and fiber cuts can be identified quickly. With a single click, engineers monitoring mobile, fixed, or enterprise networks check the root cause of alarms or performance degradation along with its impact on affected neighboring elements or on customers. Here you can see that the incident ticket information is available, so that my operations team is aware of automated actions that will follow. A service impact topology view based on service impacting alarms is also available for engineers if they want to see impacted neighboring network elements. After correlating information from multiple data sources, the automation solution correlates the alarms into a parent root cause alarm. This enables the operations team to work on a single alarm, instead of analyzing multiple child alarms, resulting in faster debugging. The next step is an automated incident ticket creation in a third-party tool. The automation solution automatically generates the tickets with owner information, root cause, network elements, and more. My operations engineers are supported through an auto-dispatch feature based on predefined rules and criteria. These dispatches can be emails, text, or WhatsApp messages. In the next step, the solution triggers automatic remediation actions based on predefined rules set by the operations team. When remediation actions are taken, the system updates the status of the correlated alarms. This informs my engineers that an automatic action has been taken and the problem is resolved. Now that 5 automated actions are complete, my telco network achieves a Level 3 autonomous network status. To evolve the network from Level 3 to 4, the solution utilizes its AI capability for performance forecasting and anomaly detection. This helps the operations engineers to identify problems before a network issue or alarm is raised, providing enough lead time to act before a service or customer is impacted. In this final step using AI, we achieve end-to-end automation of the network and service operations center, and the evolution to Level 4 autonomous network is complete.
Excellent. Okay, so I hope you all enjoyed that demo, and I'll actually now pass this on to Aygul to take us through the next part of the webinar. Over to you, Aygul.
Thank you, Jithu. This is Aygul Aytuglu. So I'm OSS BSS BDM in AWS, focusing primarily on the OSS area. So I will start by taking a step back and look at the business side considerations that is driving the need for autonomous network operations. Our main goal in our industry is to reduce cost to serve and be agile in introducing new services, introducing new self-service consumption models like Chris mentioned, and those both are critical to gain competitive advantage. And this requires streamlining and digitizing the entire process from network plan design build, service delivery, operations, and the monetization aspects. And bridging the automation gap across this entire stream requires turning things into self-service for both internally and externally. So when we're talking about autonomous network operations, we actually are hiding the complexity and making the systems to manage themselves. So therefore, I would like to talk about 2 very important topics that we have to keep in mind. So firstly, what is the level of automation and autonomy that we have while running these dozens and even hundreds of applications that are providing those processes? So are we designing and running those applications with the automation considerations in mind? So are we really considering the infrastructure part as well? The second important point is how we are putting the data and AI, and obviously now generative AI, at the center of those processes to enhance the operations quality and efficiency, and be able to create the feedback loops in between the systems, in between the applications, to enable data-driven and automated decision-making within the systems in order to achieve full autonomy. And how we're scaling that across the entire network and services, not to stay into a very narrow, limited scope of the domain or a technology, but how we can really take that at scale. TM Forum emphasizes the importance of fully automated IT to achieve autonomous network operations. So therefore, we need to bridge the gap between the IT components and the way we build autonomous network operation functionalities. We can't really separate those 2 from each other. So are we providing an agile, scalable foundation for the systems and processes? So this is a very important question that we need to think through. And to be able to enable this streamlined end-to-end service delivery, we need to make conscious architecture decisions when it comes to the deployment models, when it comes to deploying those complicated systems. So we're targeting to increase operational excellence, right? And this requires lean and highly automated processes at every level. So not only at the logical part of the stack. And in the end, so as we all know, you are as fast as your slowest component or as agile as your least agile part of your processes. So therefore, we need to look at the entire stack from the bottom to the top. And so with that consideration, so first we need to be able to automatically scale up and down the resources based on the changing demand. So this allows more efficient use of the resources and eventually the cost optimization that we all need. And so a very important point that we sometimes dismiss as industry, as a telecom industry, our IT resource utilization when it comes to OSS BSS applications, our mission critical applications, the utilization is less than 30%, because we have to consider the peak times. We need to dimension everything for those peak utilization times, but this is causing inefficient cost structures. So we have to gain this elasticity within our systems. We even see this 30% goes less than 10% in certain areas, in certain specific capabilities, functionalities. And the second point is performance and resiliency. So operators benefit from inbuilt resiliency and high availability when they run workloads on cloud. And of course, so increased performance. We worked with one of the operators on their bespoke assurance application. So this was a monolith application which had no high availability aspects been built in. And after re-architecting that application on AWS, we observed 3 times improved performance and 48% reduced cost when running this application on AWS. And when we accumulate those kind of improvements across the stack, so this makes a very significant difference. And this simply unlocks a very significant cost saving where we can use that cost savings for further innovations. And the third part is agility. So again, this is quite important when it comes to making significant technology adoptions, technology changes, process changes, or tapping into new services, new business lines, or new markets. So it is really difficult to estimate the demand or making a very precise technology decision at the very beginning of the journey. So therefore, being able to start small, not carrying a very heavy upfront investment burden, being able to flexible in testing different ideas, testing different technology aspects, and growing as the demand grows, helps the operators to gain a cost control and gain the flexibility that is highly needed. So it is very important to highlight, so as AWS, we're working with over 80 partners in the OSS and BSS domain on reviewing the deployment architectures, on transforming the applications and become more and more cloud native, helping them with the cloud native principles, what we call well-architected framework reviews, and jointly pass those benefits to the operators together. And in that regard, we worked very closely with MYCOM. So we not only achieved a very lean cloud native architecture, but like Jithu explained, we took the application to the next level, added intelligent capabilities, AI, machine learning, as well as generative AI capabilities to the applications. So the second point that I mentioned, which is quite critical, is data and AI. So while we're transitioning towards autonomous networks level 5, so this requires having AI at the core of the design, operations, and processes to achieve that intent-driven models. So we're trying to really, rather than having the automation through scripts, through machine learnings that we have been adopting for over a decade now, but we are really targeting to have fully intent-driven models. And this requires augmenting data and AI into those complicated systems end-to-end and processes at large scale. And this goes hand in hand with the cloud native architectures and cloud deployments, because this will bring the scalability. This will bring the required technology advancements and elasticity. So we provide complete set of services to unify the data and create the way to manage the data in a consistent way. Right? So the way the data is stored, curated, structured, governed, analyzed, visualized becomes easier on cloud. And one of the important reasons for that is not only having access to a wide set of AWS services, but also leveraging the pace of innovation, the R&D investments that we're making, especially when it comes to the generative AI, like very fast-paced technology advancements. McKinsey estimates 140 to 180 billion productivity gains with the adoption of generative AI in telecom industry specifically. And we're already seeing some production deployments of several use cases. So one of which is creating a model which is trained with the operator's decades worth of network design documents in many different formats. And with this generative AI application, the operator gained 30% reduced time in creating new network design documents. And this helped them to have a consistent quality across their entire team. And the other one is on the orchestration side. So we worked with one of our partners in creating orchestration flow optimization recommendations. We worked with a network equipment provider on building a small language model trained with their product documentation and to have engineers on troubleshooting, configuration checks, and configuration creations. So another one is becoming more and more popular network digital twins for impact management, better planning, or better troubleshooting and problem resolution processes. And we worked with MYCOM on Network Genie, so a generative AI assistant for NOC/SOC teams, but also a great help to provide some explanatory details for the executives as well. And our approach to generative AI has 3 layers. So this layered approach is very important to understand how different components work together to enable an AI-powered automation. So at the bottom layer, at the foundation layer, we provide the underlying infrastructure, that is specialized hardware for training and running generative AI applications cost efficiently and with high performance. So cost efficiency is very, very critical, as we all know, when it comes to generative AI applications, especially when it comes to the training. So at the platform layer, so we provide services to build generative AI applications or customize AI models. So with Amazon Bedrock, we provide API access to a wide range of different models to use to compare the results and customize those different models. And we provide guardrails to help building safeguards like filtering out hallucinations, detecting PII data on prompts and responses of LLMs to comply with the privacy considerations, and provide security services like encryption for data in transit and at rest. And at the top application layer, we provide ready-to-use generative AI solutions like Amazon Q for Builder in order to help the software developers to gain further productivity. And this is being used by BT, so they are helping their software developers, and they have already shared some benefits, some productivity gains with that service. And as AWS, we're providing a democratized access to this rapidly evolving technology and provide the right infrastructure options to gain cost efficiency and cost control. So that's very, very important. And lastly, so on that topic, I would like to share generative AI maturity interactive tool, Gamut, that we built together with TM Forum. So I think link has been shared. Gamut is an AI maturity model assessment based on 6 pillars. So built on the data from over 200 leading AI experts. And it's worthwhile to take a look into that if you haven't done it yet. And With that, I will hand it back to Jack for Q&A. Thank you.
Thank you very much, Aygul, and thank you, Chris and Jithu, as well, for your presentations. We find ourselves at the Q&A part of the webinar. So if you've got any questions you want to pose to our presenters, pop them in the chat and we'll answer them now. We have one that's come in through the course of the webinar. If we can bring it up on the screen, I'll start reading it out. And I think this one, Jithu, I'll direct to you. So post AI prediction, how do we verify the prediction is being realized? And does it set some sort of threshold of KPIs to confirm the prediction is being true to act? I can try and bring it up on screen. I don't want to mark it as answered. Is it going to go? There we go. Right, it's on screen now for everyone to see as well. So Jithu, over to you.
Yeah, sure. That's a great question. I think we actually kind of do this validation at all levels, right? One is pre-running the machine learning models. And then actually, once we actually identify those anomaly scores for customer network segments and KPIs, for individual KPIs, we then actually sort of look at their loss functions and the MAE, the mean square error, and as well as the accuracy parameters. Once, we've actually predicted, and we always actually sort of look at the past X weeks of data where we actually used to predict in order to actually then go and check, what kind of retuning of the model that actually needs to be done, and hence why the repredictions which are actually done are based on retuning the models, and that's actually closed loop feedback. Secondly, we also actually, when we do apply some of the auto remediation based on some of the machine learning and data patterns and so on, we always actually compare the post and the pre, and in terms of if the tickets have actually kind of fixed those specific issues, in order to actually ingest those tickets that are actually sent to the ticketing systems to actually see if the root causes actually still persist. And hence the remodeling or the retuning also actually happens at that level as well of retuning.
Cool, thank you, Jithu. I think another one for you, I'll bring this up on screen. Does the Gen AI or agent-based solution allow you to govern and adapt telco processes, e.g. device onboarding?
Yeah, maybe I'll actually kind of provide the first version or the first half, and then I'll actually maybe allow Aygul to also actually sort of add on to that. I think, yeah, with respect to the Gen AI portions, as we actually said, we use, with fully managed services with Amazon Bedrock, and then we actually kind of go from data analysis, output, natural language prompts, and predefined and suggested queries. And this is where your question actually comes in, right? The library of predefined and suggested queries for quick access to commonly used analysis prompts. And then it also actually contains user contributed prompts to actually contribute user queries to the library for knowledge sharing and collaborative analysis that can actually be expanded for prompt scheduling, as well as for customized reports as well, to actually generate some of those relevant insights for facilitating the decision-making process. Maybe Aygul, do you actually have anything to add on that, on how it actually works on your side?
I think that's spot on. And of course, there are multiple aspects which will define the accuracy and the success rates when we're building those kind of models. So what type of model we have chosen, how we have trained those models. So I think it's really, so what we know is there's no single model is the right fit for a specific all use cases. So I think it's also a matter of selecting the right models for the right use cases and really being able to benchmark the outcomes accordingly.
Cool. Thank you very much. So we've got questions coming in thick and fast now. I'll bring the next one up on screen. So this is both for Chris and for Jithu, I think. Based on your survey and solution presentation, we've got mobile and broadband implementation with the assurance solution, but are there any examples of an optical network use case? Have you seen any, Chris or Jithu? Do we offer any?
Yeah, I can go first, and then maybe actually also let Chris on some of those. So I think fixed broadband combining access and IP core, especially in the last mile on the fiber broadband, optical network is actually some of the key autonomous network evolution use cases that we are solving, where we are able to actually automatically identify the impact of those OLTs and the connected subscriber base to uplink issues, number one. Number two, the big problem also which CSPs face is the impacted passive equipment and the subscriber experience due to service degradation, which we are actually solving over here. And then the next one is, of course, to actually look at the specific auto ticketing or auto dispatching scenarios to the end subscriber base by actually combining, the specific OLT pre-aggregator routers to edge devices to the applications that are actually running on those optical network as well, where we actually talked about this triple correlation problem. And then the auto remediation use cases, we have a whole range of auto remediation, such as the H323, the OLT port resets, the conflict parameter changes with respect to, wavelength division multiplexing on the transport devices and things like that, right? So we are happy to actually sort of share some of those examples also offline after this webinar.
Yes, and I would like to add, basically, we are also moving to the next question about the automation in the optical network. I think that there is a perception that the optical and transmission networks are less automated, but contrary to that, I see many examples of highly automated solutions there. Recently, I was reading about a solution with an upgrade in subsea cables with an advancement to 800 terabit per second capacity, and this solution is empowered only by automation and by cloudification and not cloudification, but disaggregation of this network solution. So it is a solution that's highly automated, that is very well monitored to understand degradation and choose different paths or different modes, to be honest. This is my understanding. So yeah, optical is not that backwards as we tend to think.
Thank you, Chris. Thank you, Jithu. I guess this next question is partly towards that. I'll bring it up on screen though as well, saying optical networks are kind of the poorer cousin being left behind at level 1 and 2, behind other domains which are already at level 3. What's the root cause in your opinion? Touched on elements of that, but if you both want to tackle that one.
Yeah, so I think we did a whole webinar first of all on automation of FTTX networks, and you're more than welcome to actually sort of have a look into one of those, which we actually did, primarily actually focusing on the FTTX networks and so on. I think where we have the key issues is the last mile when it comes to FTTX and optical networks, right? As you say rightly, initially it was actually left behind, but with actually kind of looking at the high bandwidth, high capacity, looking at the broadband networks that are actually serving OTT applications, two or three things that we are actually kind of seeing there, right? One, the last mile, as I actually mentioned, and how do we actually sort of look into the degradations from OLTs to CPEs, and accurate modeling of that in the service models are not actually happening with the topology, and bringing the real-time topology back into the service models, which is what we've kind of actually perfected working with customers, right? On how do we actually automate the topology information of that last mile, right? Including the OLT to CPE to actually the subscriber bases. And second one is actually some of the identification of the fiber cut related issues when it comes to the optical fiber broadband and so on. So how do we kind of quickly look into the auto dispatching that I actually kind of mentioned, and most of that auto dispatch use cases actually for us are lying in that area. And then specifically when it comes to the changes with respect to the configuration parameters of the optical network devices and the impacted passive equipments, right? where the service degradations is something that we are actually observing, and the correlation of that with the inventory. And also, we actually also look at some of those high value subscribers which are actually connected into the optical network as well, right? We also do that CRM to workflow mapping, that we actually provide some of that remediation techniques, right? Is some of the root causes that we are automatically identifying. And lastly, I think, how do we actually then look into the isolation of those actually specific issues where you have subscriber experience due to uplink issues or whatever, as well as the signal levels that are actually received by those optical levels, those root causes that we have kind of, without the use of like expensive probing equipments with the OSS data, we have been able to actually look into that very much in detail through those root causes.
Cool. Thank you very much, Jithu. We've got time for one more question before the kind of autonomous network sort of Damocles comes crashing down. So let's go to a follow-up question. Can we read, I'll take this off first. Can we read vendor data sheets, data dictionary, and onboard device integration to PMS? Is that one for you as well, Jithu, or?
I mean, can you put that question on the screen?
Sorry. Yeah. Okay. So using Gen AI, can we read vendor data sheets, data dictionaries, and onboard device integration to PMS?
Yeah, again, maybe it's a two-part answer, I guess, we can give between myself and Aygul. I think, firstly, with the data analysis and output, through the natural language prompts and the input data that we are obviously sort of feeding into the library of predefined or suggested queries, will actually have analysis of thousands of on devices that are actually onboarded, including the network entities and application data in the real time. And second one is actually how do we then look into this high scalability and low response latency, right? In order to actually query those specific data sheets where we would have actually built some specific connectors to build that, the data output models in order to, after querying some of those complex data sets through numerical data analysis or tables or textual summaries that we actually take into account, including, data sheets that can be actually fed in. And then the persistent user sessions for prompt scheduling and to actually answer some of those queries based on the root causes that we will actually build in that library is based on those patterns as well. Anything more to add for you? Aygul, you're on mute.
I can't go off mute. I hope you can hear me.
Yeah.
Right. Okay. So yeah, to build on that, indeed, so either data sheets can be used as a data source to point the AI algorithms to and do the search, but also like what we have done with a network equipment provider, this can be a training input as well. So we can train the models using the data sheets in order to be more precise on the outputs. I think it depends on what we're trying to achieve. If you're trying to be a bit more precise, a bit more narrowed down on a certain technology with a certain vendor, maybe this will become more of a how the models will be trained with those data sheets, with those documentations. But if you're trying to do a bit of a broader search across all different vendor data sheets, then like Jithu explained as well, so we can point the models to the data sheets and then leverage the quick and fast research capabilities for sure.
I think that's what we also actually call this as small language models with respect to the different data sources that can be fed into the LLMs as well. Yeah. Yeah.
Cool. Well, thank you very much. That was a very healthy Q&A. It's a lovely thing to end the webinar on. So it would be remiss of me not to share a couple more things up on screen. Let's do a call to action. We had a news item here at MYCOM OSI at the start of early last year about our work with an operator in the Philippines, Globe, with some automation of their NOC. So there's a link to that news item there. Everyone here in the webinar will be in some form or another in the Glastonbury of Telco, which is MWC in Barcelona next month at the start of March. So if anyone here would like to come and have meetings with us, please do reach out to us. We've got stands, we've got meeting rooms, we'll be there. We can share a copy of the recording of this webinar, the slide deck, the demo. I'll probably do the follow-up email tomorrow morning just to give us a little bit of time after this. But thank you very much for joining and being a very polite and courteous audience. And thank you very much to Chris, Jithu, and Aygul for some brilliant presentations. Yeah, thank you very much. Hope we'll have a good evening.
And thank you, Jack, and everyone for actually attending the webinar. Thank you.
Thank you.
Bye.
Cheers.